Hello, space lovers. Welcome to Cosmic Hunt X, the ultimate destination for all things related to the vast universe and celestial bodies. Today, we have a very special report for you. We are going to explore the dark universe with Euclid, a new space telescope that will revolutionize our understanding of the cosmos. But before we do that, let me ask you a question. What if I told you that most of the universe is invisible to us? That there is something out there that we can't see, touch, or detect, but that shapes everything we know and love. Sounds mysterious, right? Well, it is. And it's also true. Stay tuned to find out more. The mystery I'm talking about is called dark matter. Dark matter is a mysterious substance that makes up most of the matter in the universe, but we can't see it directly. We only know it exists because of its gravitational effects on normal matter, such as stars, galaxies, and planets. Dark matter holds these structures together with its invisible force, preventing them from flying apart due to their own motion. Without dark matter, there would be no galaxies, no stars, no planets, and no life. But what is dark matter exactly? And where does it come from? Well, that's the million-dollar question. Or rather, the billion-dollar question, because that's how much money has been spent on trying to find out. Scientists have been searching for dark matter for decades, using different methods and experiments, such as underground detectors, particle colliders, and space probes. But so far, they have found nothing. No trace, no signal, no clue. This has led some scientists to doubt the existence of dark matter altogether. They propose alternative theories that try to explain the gravitational anomalies without invoking dark matter. For example, some suggest that gravity works differently on large scales than on small scales, or that there are extra dimensions of space that we can't perceive. These theories are very exotic and controversial, and they have their own problems and challenges. So who is right? Is dark matter real or not? And if it is real, what is it made of? Is it a new type of particle that we haven't discovered yet? Is it a primordial black hole that formed in the early universe? Is it something else entirely? These are some of the biggest questions in physics and cosmology today, and they are also some of the questions that Euclid will try to answer. Euclid is a new space telescope designed to study the dark universe. It is a joint mission between the European Space Agency and NASA, launched in June 2023 from French Guiana on board an Ariane 5 rocket. Its main goal is to study not only dark matter, but also dark energy, another mysterious force that causes the universe to expand faster and faster over time. Together, dark matter and dark energy account for about 95% of the energy content of the universe, but we don't know what they are or how they work. Euclid will try to shed some light on these mysteries by observing billions of galaxies across a large portion of the sky. By doing this, Euclid will be able to map the distribution of dark matter in space and time, and test how dark energy affects the expansion and evolution of the universe. But how will Euclid do this? Well, Euclid has two powerful cameras on board: VIS, visible imager, and NISB, near-infrared spectrometer and photometer. These cameras allow Euclid to capture images and spectra of different wavelengths of light from different sources in space. The VIS camera uses CCDs, charge-coupled devices, to record visible light, similar to digital cameras. The VIS camera has a resolution of 600 megapixels and a field of view of 0.5 square degrees. This means that it can capture very sharp images of very large areas of the sky at once. The NISB camera uses H2RGs, Hawaii 2 RG detectors, to capture near-infrared light. The NISB camera has a resolution of 300 megapixels and a field of view of 0.75 square degrees. This means that it can capture very sensitive images of even larger areas of the sky at once. The NISB camera can also split light into its spectrum using a grism, a combination of a prism and a grating. This allows it to measure the redshift of galaxies, which is a measure of how much their light has been stretched by the expansion of the universe. By measuring the redshift, Euclid can determine the distance and the velocity of galaxies. By measuring the shapes, positions, colors, and distances of galaxies, Euclid can map the evolution of dark matter and dark energy in the universe. For example, Euclid can see how dark matter clumps together to form large structures, such as galaxy clusters and filaments. Euclid can also see how dark energy affects the rate of growth and the shape of these structures over time. But before Euclid can do all this, it has to undergo some testing and calibration. The cameras have been rigorously simulated and experimented on Earth before launch, but they also have to be checked and adjusted in space. This is not an easy task, as there are many challenges and uncertainties involved. For instance, Euclid has to deal with radiation, which can damage the detectors and affect their performance. Euclid also has to cope with low temperatures, which can cause thermal contraction and expansion of the instruments and the spacecraft. And Euclid has to calibrate for precision, which means that it has to correct for any errors or distortions in the images and spectra. But despite these challenges, Euclid has been very successful so far. It has confirmed that its detectors and optics are working as expected, that its images are sharp and clear, and that its accuracy is within the required limits. And to prove it, Euclid has sent us some sample images as a test. These images are not the final ones, but they are already impressive. Take a look at this one. This is a patch of sky captured by the VIS camera. It contains about 100,000 stars and galaxies, some of them very faint and distant. You can see how high the resolution and how large the field of view of the VIS camera are. And here is another one. This is a patch of sky captured by the NISB camera. It contains about 200,000 stars and galaxies, some of them even fainter and more distant than the ones in the VIS image. You can see how versatile and sensitive the NISB camera is to near-infrared light. And here is one more. This is a comparison between the VIS image and the NISB image of the same patch of sky. You can see how different they look, as they capture different wavelengths of light from different sources. You can also see how both cameras offer superior performance compared to other space telescopes, such as Hubble and James Webb. These are just some of the sample images that Euclid has sent us so far, but there are many more to come. Euclid will start its official science operations in 2024, and it will observe the sky for 6 years. During this time, Euclid will collect a huge amount of data and images that will help us unravel some of the biggest mysteries of the universe. But Euclid is not alone in this quest. It is part of a larger family of space telescopes that are working together to explore different aspects of space and science. Some of these telescopes are already in orbit, such as Hubble, James Webb, Chandra, and Gaia, and some others are planned for the future, such as WFIRST, Athena, and Lisa. Each of these telescopes has its own strengths and capabilities, but they all share a common vision to expand our knowledge and our horizons. And you can be part of this vision too. You can follow Euclid's progress and discoveries on its website, where you can also find more information about its mission, its team, and its partners. You can also subscribe to our channel, where we will keep you updated with more news and videos about Euclid and other space topics. Thank you for watching this video, and remember, keep looking up.